Hello students, and welcome to this video. In this I will discuss some important topics. This is annexure A to part 2 video which I just recently posted to you. Now in this video I will discuss these topics: transition probability, allowed transitions, and forbidden transitions. These are important from examination point of view. Now let us first take transition probability. It is not always necessary that the molecules exposed to radiations will give electronic spectra. Therefore, the probability factor is also considered here. Now, this is so because the radiation's absorption depends upon number 1, delta E, energy difference between two levels. Number 2, the electronic environment, and third, which is most important, is the orbital planes alignment. Hence, the chances of occurrence of a transition is called its probability. Now, let us first take this term allowed transition. Now, these transitions have absorption maximum value more than 10 power 4. Epsilon max value is greater than 10 power 4, 10,000. So these are allowed transitions. Now these have high occurrence probability because of same orbital plane of initial and final state orbitals. Lobes of orbitals overlap to greater extent. They lie in same plane, so they overlap effectively. For example, in case of butadiene, this is butadiene molecule. For pi to pi star, E max value is 20,900, so it is allowed. It is more than 10 power 4, so it is allowed transition. Now, what is forbidden transition? These have the absorption maxima value less than 10 power 4, very much less than 10 power 4. Epsilon max value is less than 10 power 4, then it is forbidden transition. Now these have less occurrence probability because of different orbital planes of initial and final state orbitals. The planes on which orbitals are present, initial orbital and final orbital, they are perpendicular or at some angle theta, so they are not on same plane, so the overlap is not effective. For example, in case of carbonyl groups, despite very less delta E for n to pi star, you can see here the difference between n to pi star energy level is very less, but the Emax value is below 100. It is very low. So this is the forbidden transition. Now this is because the orbital planes of n and pi star electrons are perpendicular in this case. These overlap to very little extent. Hence this transition n to pi star is classified as a forbidden transition. Now conclusion: delta E value, energy required for particular electronic transition, is not the only factor which decide its feasibility. Instead, the orbital planes and their extent of overlapping, how effective is the overlapping, that is important. Now you can see, for example, formaldehyde molecule, and now this is formaldehyde molecule, pi star and pi orbital lie in same plane, so this transition is allowed. They are in same plane, this is allowed. Now this is now non-bonding electrons plane which is perpendicular to pi bond. So in this case, this transition is a forbidden transition. This transition is forbidden, n to pi star.